Hey guys, it's Mr. Grady here. Let's talk about what we're going to learn, why we're learning this, and how you'll know if you've successfully learned everything we need to learn today. So, today we're going to be looking at scientific notation. So when we talk about what we're learning today, you're going to be able to convert between standard form and scientific notation to write extremely large or extremely small values in a more concise way. So why are we learning this? So basically, in order to save time and effort when we have to work with extremely large and extremely small values. And then how will you know if you've successfully learned everything that I needed you to learn today? So when you're given a really large or a really small value, you'll be able to write the value correctly in scientific notation, or when given a value in scientific notation, if you can write the value back into standard form, then you'll have been successful. So if you're like, well, I don't know what scientific notation is, I don't know what standard form is, how am I going to be able to do this? We got you covered. So we're going to go through that today. Now before we start, this is my first video since spring break, so I'm going to take you back. Over spring break, I saw the craziest thing. So over spring break, there was this news story, it was really weird, that a burglar broke in and stole 100 pounds of soap. So maybe you saw this. There was this burglar, he broke in, stole 100 pounds of soap. But the crazy thing is he made a clean getaway. Yep, clean getaway. Get it? Soap, clean getaway. Yeah. Alright, so let's go ahead and get started now. So I need to meet you over at M543. So go ahead and open up your pages to M543. So the top is section 3 that says the big and small of it, scientific notation as we talked about. So M543. Hopefully you've had a chance to get there. And we're going to flip forward to M544 and look at what the getting started talks about. So it says, in the blink of an eye. So if we read through this, it says your childhood will be gone in the blink of an eye. So that's just kind of a phrase or a saying that people have said. So has anyone ever told you not to grow up too fast? Or have you heard something similar to this? Have you ever thought about how short a blink of an eye is? Or how many times you blink in an hour or a day or in a year? So let's look at question number 1 here. It says if the average person blinks once every 3 seconds, so on average every 3 seconds you blink. Now your body is crazy, it just does this, you don't even realize it, you don't notice it, you don't have to tell your body to blink, it just does. Kind of like breathing. How many times have you blinked in your lifetime? So just think about that. How many times do you think you've blinked in your lifetime? So here's what I'm going to do. I'm going to give you a few minutes here to go ahead, and any way you want to try and figure this out, it's on you. This will just kind of be our getting started, our warm-up, get your brains working today. I want you to just to estimate and calculate if you blink once every 3 seconds, how many times you think you have blinked in your lifetime. So I'm going to start the timer. Again, this is just whatever way you think you can get this figured out. Okay, ready? Go. Alright guys, your 4 minutes is up, and again, it was just any way that you wanted to try this or attempt this question. Well, let's look at how I did it for my age. So if you want to look at mine, I started with each minute. I took what they gave us, that we blink once every 3 seconds, and divided 60 seconds in a minute by 3, which gave me about 20 blinks per minute. From there, I moved into each hour. So I went from 20 blinks times 60, and that gave me 1,200 blinks in an hour. As you can see from there, I went from hours to days, and I took my blinks per hour times 24 hours to get my amount per days, 28,800. Then from there, I went to each year, so I took my blinks per days times 365 days to get this pretty large number, which is 10,512,000. So up to this point, my work and your work would be the same, because so far it's just been based on what they told us for 1 year. So for all of us, this is about how much we blink in a year. Now for my lifetime, I'm 28 years old. Now obviously there's some months and some days, but I just went off of the years that I am, which is 28. So I finished mine up by multiplying that amount per year times 28 years, and it gave me this amount, 294,336,000 blinks in my life. So if you think about it, that's a whole lot of blinks, okay? Now again, your answer is probably different because you're not 28 years old. Depending on your age, here are the totals that the book came up with for how many blinks you might have in your lifetime. So as you can see, each one of us has had a lot of blinks in our entire lifetime, and we don't even realize it's happening. Our numbers that we get are extremely large numbers. These are very, very, very big numbers. Today, everything we work with will either be a very big number or a very small number. This is just to get our brains thinking and to get us started. Let's actually go on now and look at what we're going to be learning. So if you guys could join me at page M545, it has some writing up at the top, but basically we're going to summarize that because of time. It's basically talking about this class that's trying to figure out how many blinks their entire class would have in a year. Well, in doing so, they come up with this number that's up at the top. So here's a number that they come up with. So I want you to take a second and I want you to think about how you would actually say this number. We talk a lot about saying numbers correctly. So I don't want to hear, oh, this is 245280000. This actually has a name. So I want you to take a second and think about how you might say this out loud. So think about it. So I want you to turn to your table partner now and try and say this number out loud. Go. Alright, so if we said this correctly, we know that this is our first couple numbers. This is the hundreds place. Then we get into the 100,000s place. Then the 100 millions place. Then now we're in the billions place. So this is 2,452,800,000 blinks. This is the number they come up with. Now what they did is they ended up typing this into their calculator, and based on the different calculator they were using, here are the answers that they got on their calculators. So here's what I want you to do. You're going to pick up your calculators. Obviously we won't have the commas typed in. The calculator will do that for you. I need you to go ahead and type this number, exactly how it's written, into your calculator and press enter. Okay, so I'm going to give you a second. Type 2,452,800,000 into your calculator and press enter. So depending on which calculator you're using, if we use just our regular blue TI calculators, ours probably ends up looking like this answer in the middle. So you're going to have a decimal, and then the letter E, and then a 9. Now if you're Mr. Schalk's kids, I know sometimes you guys use the graphing calculators, yours will actually type it out for you, and that's totally fine as well. My kids should look like this one in the middle, hopefully. So what does this all mean? On the next page, so if you go to page M546, we have several things that we read, and then it concludes with question number 2 down here at the bottom. So we're going to save some time here, and instead of just sitting here reading it like robots, I would rather write some things down. So we're going to take some notes at the bottom of page M546. So you have some room at the bottom. The first thing that I want you to write down at the bottom of M546 is this word here, standard form. Everybody say standard form. One more time, say standard form. So write the word standard form, and our definition for standard form is just how we normally would write numbers. So if I just look over here to where I have the page written, 46. 46 is in standard form. That's just normally how we write. The number 5. 5 is in standard form. That's how we write it. When we go back to our big number over here, 2,452,800,000, 452,800,000. This is in standard form, just the normal way that we write numbers. So up until now, this is really all we've talked about before in math class. Everything we've done has been in standard form. One more time, say standard form. Okay, so today, obviously, our new goal is to learn about scientific notation. So I want you to write down scientific notation. Everybody say scientific notation. One more time, say scientific notation. So jot that down, and instead of just having a definition, we're going to explain what it really looks like. So for scientific notation, it's always a number first. We'll talk about the things that have to go with that number. Always times 10. Everybody say times 10. One more time, say times 10. So scientific notation will never be times 8 or times 7 or times 13. It's always times 10. And then we always will have some exponent up here. So it's always going to be written in this form. Now there are some specifics that go with it that we're going to discuss, but scientific notation is always a number times 10 to some power. So as we talk about what goes in each place, like I said, there are some criteria for each number. So if we look at the first blank here where I have my first number sign, this number has to be equal to or greater than 1 and less than 10. So this number has to basically be between 1 and 9 and 99 hundredths. Now we can obviously have more decimals, 99999 repeating, but it needs to be between 1 and less than 10. So that's the number that has to go there. Okay? This number is called the mantissa. Another weird word. We've had hypotenuse recently. We've had Pythagorean theorem recently. This is called the mantissa. Everybody say mantissa. One more time, say mantissa. Last time, say mantissa. All right, so another weird word. So when we talk about, oh, what's the mantissa, we're talking about this first number here that has to be greater than or equal to 1 and less than 10. Okay, let's move over to our exponent. So it is obviously called an exponent, but in the book they're going to sometimes call it the characteristic instead of just calling it an exponent. So when we say exponent or we say characteristic, it means the same thing. So everybody say characteristic. One more time, characteristic. Okay, so for the characteristic, it has to be an integer. Now, a few weeks ago, we took some Cornell notes over integers. We talked about that an integer is any whole number that's positive or negative. So this number can be negative. That's totally fine. An integer makes our exponent, means that it can be negative. Okay, so let's think about the process of this. I want you to write this down. So we started off, if you remember on the other page, with this number in standard form. So go ahead and write this down below. We started with 2,452,800,000. This is in standard form, as I said a minute ago. So we started off in standard form. We typed it into our calculator and pressed enter, and it gave us 2 and 4,528 10,000ths E9. We haven't really talked about what this really represents, but I want you to notice something. If you notice, the 24528 is the beginning of our number in standard form, 24528. Okay, so maybe that has something to do with it. So this is what it looked like on the calculator after we pressed enter. If we were going to then convert this into scientific notation, our number would look like this. So go ahead and write this down. So again, our mantissa has to be bigger than 1 and less than 10. So we have 2 and, still have our decimal, 4,528 10,000ths times 10 to the 9th power. So if you look at some similarities between our calculator and our scientific notation, really that letter E is taken out and a times 10 gets put in its place. The characteristic or the exponent is our 9 that it shows up on the calculator. So decimal stays the same as what they gave us on the calculator. E becomes times 10, and then 9 becomes to the 9th power. And again, that's in scientific notation. So we can take a number in standard form, go from standard form to the calculator to scientific notation. So now if you could meet me at M547, that's where we move on to in our lesson. Up at the top there is some directions, and I'm going to go ahead and read these. As I stop, remember everybody reads the next word. We're a team. Everybody's going to read with us. So let's go ahead and let's look through this. So 3 says, again, you guys follow along, use your or scientific to explore large and small numbers. So again, my class we have scientific. Mr. Schrog, you might have graphing or scientific calculators, either way. Let's look down at A. Again, everybody following along. Enter each number into your and complete the. Alright, so if we look at what they've given us a number. So you have these four numbers in the left column, a calculator display column, and what does this mean? I went ahead and I wrote something up above where it says given numbers. I wrote standard form. Remember, that was one of our words we talked about earlier. I want you to write this. So go ahead and write standard form where it says given number. So these numbers are all written in standard form like we normally would write numbers. Now we have some extremely large numbers at the top. We have some extremely small decimals down here at the bottom. But you're writing standard form. So let's do one of these together, and then you're going to have some time to work. So as you can see in the first one, I took my calculator and I went ahead and I just typed in that first number that was given to us. So I'm going to give you a second. Go ahead and type in our first number, which is 35,400,000,000. So once I have this typed in, I'm just going to press the answer key, and it's going to convert mine into something similar to what's on my screen. Now again, depending on the calculators that you're using, it might be a little bit different. It might actually say times 10. I don't know. So depending on what calculator you have, it might look a little bit different, but it's probably going to give us something that looks like this. So on my calculator, it shows me 3 and 54 hundredths. Again, they're getting that from the beginning of our number over here. E10. So if you remember back to before, the E is just taking the place of times 10, and then this 10 becomes our exponent or our characteristic. So what we're going to do now with that is we're going to go back and we're going to start filling in this table. So the next thing that I've done is I've gone ahead and I've filled in what I saw on my calculator into the calculator display. So this is the number that I see on my calculator, 3 and 54 hundredths, E10. And then over here it says, what does the calculator display mean? In this section is where we're going to write everything into scientific notation. So even though on the calculator we might see it differently, or we might have it exactly like this with E here, 3 and 54 hundredths E10 is really like 3 and 54 hundredths times 10 to the 10th power. So again, remember, our mantissa, our decimal, that weird word mantissa, that stays the same as your calculator display. The E becomes times 10. Then our characteristic, or our exponent, this 10, comes from the number that's next door, right here. So the 10. Again, this is written in scientific notation. So you're going to have a chance now to go through and you're going to fill in the rest of our table. I have a timer here for you, so we'll be able to keep track of where we're at. So I'm going to start the timer, and during that time you're going to be filling in the rest of this table. Ready, begin. All right, so now that our time is up, I want to give you about another 30 seconds here to go ahead and share your work with your table partner. So we're going to go ahead and begin that, and table partner number one is going to go first and share their answers, and table partner number two can either confirm the same answers or offer a suggestion if we have something that's a little bit different. Okay, go ahead and begin your discussion. Okay, so hopefully we've had a chance to discuss. Let's go ahead and actually check our work. So if we look at what's up on the screen, and again, your calculator display might be a little different than mine, and that's okay as long as we ended up with the same scientific notation for what it means. So if we look at our second value, it was 6e to the 13th, which is 6 times 10 to the 13th power. 7e, negative 7, is 7 times 10 to the negative 7th power. Remember, again, our exponent or our characteristic can be negative. That's totally fine. And then finally, we had 8 and 935 10,000ths, e negative 6, and that gave us our same decimal times 10 to the negative 6th power. So let's look at our questions down below our table. So it says for letter B, describe the characteristics for extremely large numbers. Now I want you to think about this word characteristics. Normally that means like traits, like what are the traits of large numbers? This is talking about simply the exponents. Remember, the word exponent and characteristics mean the same thing. So what they're asking is, and I've kind of cut and pasted this in here so you can use it as a guide, what do you notice about our exponents and large numbers? And then you're going to go and answer C. What do you notice about our exponents and extremely small numbers? So again, only looking at our exponents. And then it says for D, describe the mantissa in each. Remember, the mantissa is our decimal or our whole number for each of these values. So you have a 2-minute clock that's going to be running. At the end of 2 minutes, we're going to go back and we're going to check this. Ready, go. All right, so since our time is now up, I would like for you to partner share this. Partner number one, you're going to say your answers for B and D. Partner number two, you're going to say your answers for C and D. So again, partner number one has B and D. Partner number two has C and D, and I'm going to give you about a minute to do this. Ready, go. All right, so now that you've had a chance to share with your table partner, let's go ahead and let's check some answers that I came up with. So B said to describe the characteristics. Remember, the characteristics mean the exponents of large numbers, and when it's a large number, our exponent should be positive. So if you notice this, our exponents were 10 and 13. So they're pretty big and they're positive numbers. Then it said to describe the characteristics for extremely small numbers. So remember, the characteristics or the exponents of small numbers ended up with negative values, -7 and -6. Finally, it told us to describe the mantissa for each. The mantissa for each example is greater than or equal to 1. Remember, we talked about it has to be, and less than 10. So remember, it has to be greater than or equal to 1 and less than 10. So the next thing I need you to do is we're going to skip a little bit ahead, and you're going to skip to page M550. So I'm going to meet you over at page M5. So you're joining me on M550, and it's activity 3-2, scientific notation in large numbers. So now, instead of just using our calculator to do all of the work, we're going to break it down and we're going to actually see and do what the calculator is actually doing when we type things into it. So in this section, the directions say, in this activity, you will practice writing large numbers in either scientific notation or standard notation. And then our directions, number 1, say write each number in the notation that is not given. So obviously, if they give us scientific notation, we're going to write it in standard form. If they give us standard form, we're going to write it in scientific notation. Now, there's a couple things we're going to jot down just as some quick notes to guide us through this, and then we're going to go ahead and we're going to get started. So here's what I need you to write down. So over to the side, there's these 4 little kind of rules to using scientific notation. So the first one talks about large numbers. So if it's a very large number, like what we're dealing with in this section, remember, we already figured this out before, but our exponent is positive. Our exponent is positive. So a large number, exponent's positive. If it's a very small number, then the exponent should be negative. And again, we've kind of talked about this already, that the characteristic or the exponent should be positive or negative based on if it's a large or a small number. Now, these next 2 pieces we have not discussed yet. This is actually what's happening on the calculator that we're going to do. So it says for a positive exponent, the decimal moves to the right. Positive moves to the right. Remember that. Positive exponent moves the decimal to the right. A negative exponent moves the decimal to the left. One more time. Positive exponent moves the decimal to the right. A negative exponent moves the decimal to the left. So now let's go ahead and let's actually do one of these. So we're going to look at A together. And A says there are approximately 3 34/100 times 10 to the 22nd power molecules in a gram of water. Now again, our job is to write this in standard form. So we're going from scientific notation to standard form. So our first thing that we're going to do is take our mantissa, remember that's 3 34/100, and we're going to rewrite that exact same number below our question. So we're going to take our number, which was 3 34/100, and we're just going to rewrite it down below. Okay. Now the next thing we need to look for is this exponent. So our exponent in this question is 22. That means we're going to move the decimal. So we're going to write this, move the decimal 22 places. Now remember, we wrote over to the left that if our decimal is positive, we move it to the right. So this is going to be moving the decimal 22 places right. Okay, so as we move this, here's what I need for you to do. If you're not writing in pencil, I need you to turn and switch and write in pencil, because we're going to actually do a little bit of work and then erase some of it for our final answer. So if we look at 3 34/100, again, we're moving the decimal 22 places right. I'm going to draw my loops, and I want you to draw it also, counting how far over we're moving. But remember, we're writing in pencil here, so we can go back and erase a little bit at the end, and I'll show you what I mean. Okay, so let's do this. So we're starting with our decimal. We're going to move it 22 places right. So we got 1 place, 2 places, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So we've moved our decimal all the way to the end on the right, 22 places, but we have all these blanks. Now we know from experience that we can fill in blanks like this with zeros. So we're going to do that. So we're going to take our pencil, we're going to fill all these in with zeros. So you're doing this with me right now. All right, so now all of our placeholders have been filled in with zeros. Now remember I said you guys need to make sure you're using pencil. So here's what the next part of this is. We're going to go back now and we're going to do some erasing. So we're going to erase all those loops we made. So we're going to go back and we're going to erase this. Okay, so yours should look something like mine now. So the only thing that's missing is our commas. So we're going to go back to our right. Now remember, this is a really big number. So every 3 digits gets a comma. So we have 3 zeros, comma, 3 zeros, comma, comma, and you're doing this with me. So once you've gone back and put your commas in every 3 place values, we have successfully done what they ask us to do. We have taken 3 and 34 hundredths times 10 to the 22nd power, and we have written that as standard form, which is this really great big number. Okay, so you're going to have a minute. I'm going to put the timer up here for 1 minute, and I want to see if you can do question B, which is 2 and 5/10 times 10 to the 13th power. So the same process we just did, you're going to take that and write it in standard form, and you have 1 minute. Ready, go. So now that our 1 minute is up, let's go ahead and check how we did. So your answer should look like mine. We have 25, and then we should have 12 zeros. So remember, it was moving 13 place values right. One of them is occupied by this 5, and then after that we have 12 zeros. Every 3 place values gets a comma. Okay, let's look at C. So C says 1 light year is, and they give us this humongous great big number. And remember, we have to write it the opposite way. So we have to write this in scientific notation. So our answer needs to look like our examples were in our first two. Remember, scientific notation is always a number, that mantissa, times 10 to something power. So in order to do that, one thing we must remember is that our number and the mantissa has to be between 1 and less than 10. So we're really trying to look at this section right here. And we're trying to decide in this number, where should I put a decimal to make that number be between 1 and less than 10. So let's think about this. If I put my decimal here in between the 8s, that means I have 58 and 8/10. And we know that's way too big, so I'm going to move it over again. If I put my decimal in between the 5 and the 8, I have 5 and 88 hundredths. Well, I know that 5 and 88 hundredths is in between 1, but it's also less than 10. So that tells us that our mantissa is going to be 5 and 88 hundredths. Remember, in scientific notation, it's always, always, always times 10. But remember, we have to have some exponent there, the characteristic. We need to decide what that number should be. So our job is to decide what number our exponent should be, and we're basically just working backwards from what we just did. We're still going to count how many place values our decimal would have to move to get from our place where we have it now in between the 5 and the 8 all the way over here to the end of our number. So we're just counting these decimal places. So let's go ahead and let's do that. So I'm going to start in between the 5 and the 8, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I just counted 12 places between where I put my decimal and where the end of my number is. So I know, that tells me that my exponent is to the 12th power. So my final answer is 5 and 88 hundredths times 10 to the 12th power. Alright, so I'm going to give you some more time again. I want you to answer D. Use the same steps that we just went to. Figure out where to put your decimal to make your mantissa between 1 and 10. After that, count your decimal places over, and that's going to give you your exponent. All right, our time is up, so let's see if we could get this one correctly done. Now remember, as we're starting this, you're trying to figure out where your decimal should go. So if I put my decimal after the 6, that's 186, way too big. If I put my decimal in between the 8 and the 6, that's 18 and 6/10, still too big. So your decimal should have been placed between the 1 and the 8, which gives us 1 and 86 hundredths. Then we're just counting our place values over to get the rest of our scientific notation. When we do that, we end up with this value written in scientific notation. So your answer should have been 1 and 86 hundredths times 10. And again, that's to the 5th power because we would have to move the decimal 5 places to the left to put it behind the zeros. So here's the next step, and you're going to get time to work on this on your own. So let's look at the directions first before we start so you understand what they're saying, and then you're going to have a lot of time to work. So as I read through this, as we did before, again, we're all a family, we're all a team, we work at this together. When I stop, everybody's reading. So everybody's following along. Number 2, it says, the estimated as of December 2016 of countries are shown. Decide whether the is written in scientific or standard. So that's the first thing you're going to have to do. You're going to have to decide which way it's written. Is it written in scientific notation or standard notation, standard form? Here we go. So we're following along at the next sentence. If the is not in scientific, explain how you know it is not. So you're going to have a little explanation of how you know if it's written in scientific notation or not. Finally, the last sentence says, then write the number in scientific. So you're going to have some time to work. 3 minutes. You're going to go through these 4 questions, A, B, C, D. Remember, your first job is to decide whether it's in scientific notation or standard form. You're going to have an explanation of how you know. So how do you know if it's scientific notation or how do you know if it's standard form? Then you're going to write. So if the number is not written in scientific notation, you're going to write the number in scientific notation. Okay, so I'm going to start the timer, 3 minutes on your own. Here we go. All right, our time is up, guys. So hopefully you had a chance to get through these 4 questions. Here's what I want to have happen. If you are partner number 1, you are going to share your answers and explain your answers for A and B. Remember, you had to have an explanation of whether or not you thought these were in scientific notation or standard notation or how you knew. So you need some sort of explanation. So A and B goes to partner number 1. C and D goes to partner number 2. A and B to partner number 1, C and D to partner number 2. We're going to go 1 minute to get through this pretty quickly, okay? A and B goes for 1. Ready? Begin. Okay, guys, so our time is up from sharing. Let's go ahead and let's check our work and see how we did. So on A, we should have had something written down that says the number was written correctly in scientific notation. So on A, it's already correct. 1 and 382 thousandths times 10 to the 9th power is totally fine, totally written correctly. Remember, our mantissa has to be between 1 and 10, which this one is. We have our exponent, so we're good to go there. So get B. This island has 50 people. So 50 people is not in scientific notation because 50 people is actually written in standard form. So hopefully you saw that this is in standard form. And when we convert this to scientific notation, we get 5 times 10 to the 1st power because our decimal just moves 1 place to be put in between the 5 and 0. So 5 times 10 to the 1st power. Let's go to Australia. 24 and 3/10 times 10 to the 6th power of people. Now here's the issue. The number is not correctly written in scientific notation because 24 and 3/10 is not between 1 and 10. Remember, our mantissa has to be between 1 and 10. 24 is not between that. So we actually had to move the decimal over 1 more place to put it in between the 2 and the 4. So we have 2 and 43 hundredths times 10, but that also bumps up our exponent or our characteristic to a 7. Finally, partner number 2 should have explained the United States as 3 and 24 hundredths times 10 to the 8th is correctly written in scientific notation. So the next page we're going to flip to is M555. I know we flipped around a lot, but I want to just get to the things that we really need. So if you could go to M555, I have placed our 4 little notes that we've already written. I put these over here so you can see them on the screen. You don't have to write them down unless they'll help you, but I'll have them up here for you to see. So number 4 says write the radius of each shape of blood vessels in standard form. So again, we're going to be taking our scientific notation and writing it in standard form. Now it's a little bit different because our exponents, if you notice, are negative on all of these, negative, negative. But we're going to go ahead and do one together, and then I'm going to give you some time to work. So A says the capillary is one of the minute blood vessels that connect arterioles and venules. The radius of a capillary is 5 times 10 to the negative 3rd power millimeters. And again, it's just asking us to write this in standard form. Well, just like before, we're going to start by rewriting our mantissa down below. So for us, it's 5. So we're going to take our 5 from our mantissa, and again, we're getting that from right here, and rewriting it down below. Remember, the exponent tells us how far to move and in what direction. So we're moving 3 places. Remember, if our exponent is negative, we have that written over here to the side, our decimal moves to the left. So we're going to be moving a decimal to the left. Now, you might be looking at 5 and saying, well, there's no decimal in 5. But remember, we can turn 5 into a decimal by putting a decimal after it, because this is really 5 and 0/10. So we're going to move this decimal 3 places to the left. 1, 2, 3. And then here's our new decimal. So like before, we're going to fill in our placeholders with zeros. So we keep our zeros. And like before, we're going to go back and we're going to erase all of our other marks. So we're going to go back and erase our counting marks. Now, if we look at our number like this, it looks kind of funny because it has this extra 0 at the end. We do not need the 0 after the 5, so I'm going to go ahead and I'm going to erase mine as well. And what we're left with is our decimal that gives us our answer. So we know that 5 times 10 to the negative third power is the same as 5 thousandths as a decimal. Okay, so what I want you to do is I'm going to put some time on here. You have the timer to look at, and you're going to do the next 2 questions, writing them in standard form. Ready, go. Okay, now that our time is up, we're going to partner share. Partner number 1, you're going to share your answer for B and an explanation of how you got it. Partner number 2, you're going to share your answer for C and an explanation of how you got that one. Go. All right, now that your 30 seconds is up and you've partner shared, let's check our work. So if we look at B and C, we see that we should have got 1/100th of a millimeter for B and 5/10 of a millimeter for C. So on B it was moving our decimal 2 places left, and on C it was moving our decimal just 1 place to the left. So now it's time for some practice. So me and Mr. Shog, we're going to hand out a paper for you to work on. The front side is simply just converting each number from scientific notation to standard form, followed by a brief summary of how you do that. The back side is converting each number from standard form back into scientific notation. So we've done a lot of practice over the last 2 days with this, and your job now is to go through and practice it. So you've got this time to go ahead and work. If you need help, raise your hand or ask your table partner. All right, guys, we're going to continue on with our practice in scientific notation by filling out this table at the top of M556. I'm going to meet you over at M556, and I'm going to set our timer for 2 minutes. You're going to have 2 minutes to fill in the blanks of this table. So depending on what they give you, in some cases, they've given you the information already written in scientific notation, so you're going to write it back in standard form. In other cases, they've given it to you in standard form, and you're going to convert it over here to scientific notation. Or the last question, again, scientific notation back to standard form. So again, just further practice on what we've learned already. You have 2 minutes. Like I said, I'm going to start the timer. You can go. Okay guys, now that your time is up, we're going to partner share this. So partner number 1 has the first 2 blanks, partner number 2 has the second 2 blanks to finish up our practice. So now that you've had a chance to share, let's go ahead and check our work real fast. So I'm going to leave the answers up for just a second and let you check your work. One thing I do want to point out is the labels that we have. So on our first answer, we should have had meters, then kilograms. On our second answer, then meters and meters again. So we've talked about this a lot in the past. If there is a label necessary, make sure you have that label. So let's look down at the bottom of M556. It says writing numbers in scientific notation is useful when comparing very large and very small numbers, as we've talked about. Now our directions are going to ask us to do some comparing. So they give us 3 symbols to use. If you look, they give us these 3 symbols here. Now hopefully those symbols are not anything that is unfamiliar to us, but I do want to point out over to the side, I have kind of given us an explanation of what the symbols mean just to refresh our memory. So our first symbol, which opens to the right, is a less than sign. Everybody say less than. Our second symbol, which opens to the left, is a greater than. Everybody say greater than. And then our final symbol is an equal sign. Everybody say equal to. And that just represents that our 2 values are equal to each other. So if we go back to our first question, question number 1, it says to compare the values, and then we're going to put the symbol in which matches correctly with our 2 values. So let's look at what we have. On A, we're going to do this one together, and then you're going to do the rest of them on your own. They've given us 2 values. So they've given us 4 5/10 times 10 to the 4th, and 1 5/10 times 10 to the 4th. So to do this, one thing we're going to start with is we're going to go ahead and write these in standard form. It will just help us compare them a little bit better. So we're going to take our 4 5/10, remember, and we're going to write it down below where we have room. Now we know that our exponent is a positive 4. Positive moves to the right, so we're going to move this 4 places to the right. 1, 2, 3, 4. Remember, we fill these in with zeros. And then we go back and we erase our counting marks. And then we put our comma in, and we're left with 45,000. So we're comparing 45,000 to, and if we come over here to our other number, 1 5/10, and again, our exponent is a positive 4, so we're moving 4 places to the right. 1, 2, 3, 4. Again, we fill these in with zeros, erase our counting marks, and we are left with 15,000. So we're comparing 45,000 to 15,000. Well, we know that 45,000 is greater than 15,000, so we're going to use a greater than sign, which opens to the left. So some ways you can remember this is our symbol needs to open towards the larger number. So in this case, 45,000 is larger or greater than 15,000, so it's going to open towards our 45,000. So now that you've seen one done, you're going to have some time to go ahead and work and do B through F. You're going to have 4 minutes on the timer, and then afterwards we'll partner share and then go over it and move on to our next step. Ready, go. All right, guys, our time is up. Partner number one, you are going to share your work and explain your work for B and C. Partner number two is going to explain and share for D, E, and F, and then we'll go over the answers real fast. So again, partner one has B and C explaining what you did, and partner two has D, E, and F. Ready? Go. All right, guys, your time to share is up. Let's go ahead and let's check our work. So again, I'm going to give you a few seconds here to go through and look and see how your answers compare with mine. All right, so let's move on to the next section on page M557, and at the top, question number 2 asks you to explain how to compare two large numbers using scientific notation. So again, going back to what we just did, it's just asking you to explain your steps or your process in this. So I'm going to give you about 1 minute in complete sentences, come up with an explanation of how to compare very large numbers like what we just did. Ready? Go. Okay, guys, our time is up. We're going to go ahead and partner share your explanation. Partner number 2 is going to start us off, followed by partner number 1. Ready? Go. So as our time finishes up for our partner share, I want to take you back to what we just finished on page M556, and let's kind of talk about what your explanation could have or probably did say. So we talked about, first of all, writing each of our scientific notation numbers in standard form. So we went ahead and did that. From there, you can compare which number is bigger or which one's smaller, or even if they're equal to. Now in this case, we didn't have any values that were equal to each other, so that's okay. But once you have written your numbers in standard form, then you're just looking at place value. So we know 45,000 has a bigger value than 15,000. Or in the case where our numbers are the same, we know that 45,000 is less than 45 million. So we're just looking at place value. So hopefully you said something along those lines. Now I want to draw your attention to something, and maybe some of you noticed this, maybe you didn't. But let's go to question 2. We're still at the same spot. I've just highlighted 2 questions that we came across on the previous page. So these are 2 problems that we already did. Now we've already said that 4 5/10 times 10 to the 4th power is less than 4 5/10 times 10 to the 7th power. And we've already said that 4 5/10 times 10 to the 4th power is greater than 1 5/10 times 10 to the 4th power. So let's talk about kind of a shortcut or an easier way to do this without writing our numbers completely out in standard form. So we're going to shortcut this. We're going to save some time as we go through it. So let's first look at our exponent or our characteristic. So in our first example, which was letter C, our characteristics or our exponent were 4 and 7. Well, if we think about place value, any number that has 7 digits is going to be larger than any number that has 4 digits. So without doing any other work, we could look at our exponents and just say, okay, 7 place values, or 7 digits, is going to be larger than 4 place values and 4 digits, so then we could have our symbol showing that and opening to the bigger number. So again, all we did was look at our exponents. Now sometimes we look at our exponents and they're the same. So if we go down to question A, we have an exponent or a characteristic of 4 and a characteristic of 4. They're the same. So from there you go to the mantissa. Our mantissa here is 4 and 5/10 versus 1 and 5/10. So if the exponents are the same, then looking at the mantissa, we know, well, 4 and 5/10 is definitely larger than 1 and 5/10, so we need to show that with our symbol of a greater than sign. So again, kind of a shortcut without doing all of the transitioning back and forth between standard form and scientific notation is to first of all look at the exponent, and if our exponent is larger, then we know that's going to be the bigger value or the larger value. If our exponents are the same, you look at the mantissa, and then whatever mantissa is larger is going to give you that value. Okay, so let's go to question 3. So this time we're going to compare really small numbers instead of large numbers. So one more time, let's just kind of discuss what we just talked about with an easier way to compare these. So if I look at this, our first exponent is -4 and -4. Those are the same, so that doesn't help us at all. But if we look at the mantissa, we have 1 and 5/10 on our right and 4 and 5/10 on our left. Well, I know that 4 and 5/10 is a larger value than 1 and 5/10, so that's going to give me the greater than symbol. So you're going to go through and you're going to finish this up, B, C, D, E, and F. If you're somebody who would rather write them all out in standard form, if that helps you to actually see the number, I'm fine with that if you want to take the time to do it. If you're somebody who just wants to compare exponents and then the mantissa, I'm fine with that as well. So listen to the full instructions. You're going to finish this section, so you're doing B through F. After that, you're going to go on to 4 and on to 5, describing the similarities and differences between the numbers. So I'm going to give you 4 minutes to go through and finish these sections, and at the end we'll look through it real fast, and then you're going to have some practice on your own. Ready, go. Alright guys, so our time is up, so I'm going to go ahead and we're going to go over our answers real fast. So let's check our work here. So our answers for A through F should look like this. So I'm going to give you a second to check your work with mine. Our answers from A through F. So what I wanted you to check our work for 4 and 5 is partner number 1, you're going to read your answer for question 4. Partner number 2, you're going to read your answer for question 5. So 1s are doing 4, 2s are doing 5. Ready? Go. Okay guys, thanks for sharing with your partner. We're going to finish up our practice of scientific notation on page M559. So we have questions 1, 2, and 3. Question number 1 says just to decide whether it's written in scientific or not, and if it's incorrectly written, you're going to explain and actually write it in scientific notation. So we did that the other day. We're going to complete the table like we've done before. And then on number 3, you're just writing each number that's in standard form into scientific notation. Finally, on questions 4 and 5, on 4, you're going to write each number in standard form, so they're going to give it to you in scientific notation. And then lastly, we're going to conclude our practice by comparing each set of number with either a less than, greater than, or an equal to sign like we have done before. You guys have done an excellent job. I know this is drug out. Thank you for paying attention, and thank you for learning, guys.